Hello Java students! In today's video we're going to talk about the particle systems that we've been learning about in class. So I'm going to talk through an example using that level 1B, a sprinkle of ball objects. If you are looking for solutions to one of the other projects that we worked in class, check the resource document. There is a link to the key for all of the solutions there. But let's talk about it so that we can make some connections between the things that we were copy and pasting in today and make sure that our understanding matches the code that we wrote. So the first thing that I'm going to do is I'm going to create a new Java class, and I'm going to remake my ball object class really quickly. So the things that I know for sure that I need is that I need to have 4 variables, x, y, x speed, and y speed. At some point soon, I will add in my constructor. And then I need to have a few methods. So I will make my public void move method, which is going to add x or increment x by its x speed, and do the same for y. Oops, equals. Cool. I also realized that for this one, I don't need any other reverse x or reverse y methods because this fountain isn't going to have anything bouncing. It's just going to have things going up in the air and then falling down. So the only other method that I need is called add gravity. And this one you copy and paste it in. What this method is really doing is, oops, let's go inside of here. It's adding something to the y speed. So let me type it out and then tell you in a second what it does, 0.6f. So it's going to show up in red for a second, and I will explain what I mean, why it's in red in just a moment. So what it's doing is it's adding some decimal amount to that y speed every time. So if my y speed is a positive number, it's going to be increasing that positive number by some decimal. If that y speed is a negative number, it's going to be slowly getting rid of that negative number by adding a little tiny bit. So if you remember in graphics, positive number of y speed means I'm moving down the screen. So if it's positive, it's going to continue to add a little bit and make that speed just slightly faster and faster and faster. In the same way that when you drop an object, as it picks up speed because of gravity, it moves faster and faster and faster if you dropped it off of a cliff. In that sense, it's got some acceleration to it. And also that when we throw a ball up in the air, and so it's going up, meaning it has negative speed, at some point it's got to stop and slow down and reach its peak and then turn around and become negative. So that's what adding on this little bit of 0.6 will do. If it's a negative number, it's negative, slightly less negative, until finally at some point it becomes 0, meaning it will stop moving, and then it'll become 0.6. And then 1.2, and then so on and so forth, and it continues to add that gravity over time and goes downwards. So that's what that add gravity method does. However, the thing that I'm adding on here, because it's not a whole number, it's a decimal, and in fact it's a float type number, what we need to do is we need to go change these to be float type data types. And a float is essentially like a double. It holds a smaller amount of space in the memory of your computer, but it's essentially a double, a decimal number is what I want you to think about it as. And so, because I know that my y speed is going to be added by that small decimal amount, I need to make for sure my y speed be a decimal number, but then I also know that my y speed is adding on to my y value. So then that means the y value itself also needs to be a decimal number. And then just for the sake of the argument, in case I want to be able to have decimal things happening in that x direction, I'm going to let them all be floats. Currently, only the y and y speed need to be, but let's let them all be. So that's why we change things to floats, and that's what that add gravity method does. Then let's go back and let's add our constructor now, because now we've got the correct data type. So now I'm going to say public ball, and I'm going to initialize some inputs. So x, y, x speed, y speed. Oops. And I'm going to set them. Wow, this is going well. Okay, there we go. All right, So now I've set up my constructor so that I will take 4 inputs, x, y, x speed, and y speed, and set them to be the variables of this class. The last thing that we were asked to do inside of our ball object is create another method called act. And this method called act is supposed to call move to make the object move in some way, and then add gravity so that we are continuing to allow gravity to occur as we run this program. So every time act is called, we will move and then add a little more gravity, and then move and then add more gravity, and then move and add more gravity. So that's the object class itself. It has that add gravity, it's got act, it's got a constructor made of float data types. And then the other thing that I told you to do was to go over and make a main graphics class that had the 4 methods: setting, setup, draw, and main. I told you to initialize the size of the window inside of settings, and then a few other things. The other thing I told you to do was to make an array list of data type ball that we're going to call ball list. And this might show up in red at first. What we need to do is we need to import array list. So let's go ahead and import it. And then inside of setup, we need to initialize that array list. Oops, sorry. So to initialize that array list, we've already created it. It's called ball list. So ball list is going to be equal to a new array list. Awesome. So now we've got the array list that will hold all of the values of the ball objects so that we can then access them. So now let's figure out and think about the action that we want to have happen. So the action that we're going to have happen in this case is dealing with some user interaction. The first thing I need to do, I'm going to have movement on my screen, so I better use that background command to wipe away the previous screens so that I don't see the path of all of my shapes. So I'm going to use that background command to remove paths. And then what I want to do is I want to check for mouse detection of if that mouse is pressed or not. So I'm going to say if mouse pressed, and we can say equals true, or we cannot. We don't have to. If this is basically saying if true, because mouse pressed is a Boolean, so we're good to leave it as is. So if the mouse is pressed, the action that we want to do here, let's write about it in pseudocode first. The action that we would like to have happen is we would want to make the fountain. And what it means to make the fountain is create some ball objects and make them act according to fountain actions. So the fountain actions that we would want to have happen is that they shoot out from the mouse location. I guess I should put all of this down on a new line. Shoot out. Shoot out from the mouse location and then fall. So in order to make all of that happen, we want them to shoot out from the location of the mouse and then fall. So that means in order to make that new ball, it should be at the position of the mouse. So let's make a new ball. I'm going to call this one ball B, and it's a new ball. And now I need to think about what are the inputs. Where should this ball be? Well, we know that we want it to start from the location of the mouse. So let's put it at mouse X, mouse Y. And then we need to have an X speed and a Y speed. And I can set this if I want to, but if I set this for a ball, then anytime I press the mouse, every ball will have this X speed and Y speed. So what I would like to do instead is make those be random speeds so that maybe one of those ball fountain particles shoots off to the right and the other shoots off to the left, and one shoots straight up and one shoots a little bit diagonal to the right and one shoots diagonal to the left. So what I want to be able to do is allow for different directions in which these little particles will move. So I'm going to allow for different directions. Make random variables for X and Y speed so that the fountain particles can go many directions. Now, if you remember from the demo, the fountain particles all start shooting upwards from the mouse, but they can go to the left or to the right. So what that means is I shouldn't really change anything or restrict that X direction, but I probably should restrict that y direction just a bit. So I'm going to make a random float data type. Float x speed is equal to, and then I'm going to say math.random. And let's see, I want that to be, for my x speed, I want it to be a random number. It can be positive or negative. So let's stretch it out over, values of, I think my directions say -4 to 4, but let's stretch it out over a slightly different distance so we can see what would happen. Let's stretch it out over a distance of -3 to 3. So in total, from -3 to 3, that is a distance of 6. And then if I want to shift it down so it starts at -3, I would need to shift it down by 3. Now this is mad at me for the moment because math.random is a double and we need a float, so then we're going to need to cast this to be a float data type. And then we can put in that x speed that we found. So maybe I'll call this random x instead so that we know that it's unique and different. So we'll put in that x speed. Then we need to do that same idea, but find one and create one for our y speed. So then we'll create another one. It's going to be a float data type. We'll use math.random. And this time, our y speed, we want it to start shooting up from the mouse. So in order to ensure that it's going to go up from the mouse, we need to make sure that that speed is in fact a negative number. And it can be as big or as little as a negative number as we like. I think I said to make it between -15 and 0 in the instructions. So this time, just for the sake of the argument, let's make it between -10 and 0. So a distance of 10, and shift it down 10 so that it starts at -10 and goes all the way up to 0. Because remember, if it has no y speed to start, we're going to add gravity, so it's still going to end up falling. So it's okay if that random number is 0. It's okay if that random number is 0, so we don't need to account for getting rid of the 0 case. So then we'll put that random y as our y speed. Great. So all of that was just to make the ball object. And now that we have that ball object, we need to go put it and add it to this list of ball objects, because this is the list that we will access in order to make the actions appear on graphics. Remember, a ball object doesn't actually draw an ellipse. The ball object just holds the variables that we will use later to draw the ellipse. So my last step here is I want to add this new ball that I've made to my ball list. So I'm going to do that by saying ball list.add B, because that's the name of this ball list here, is B. Okay, so now all this is going to do when I press down on my mouse is create a ball and add it to the list. So let's try this out and see how this runs so far. The only other thing that I want to do is let's just make a print statement of the array list. Oops, I did that wrong. Sorry, hang on. Let's make a print statement of that ball list, and we'll try to keep track of it in the console while we run this program. So when I run this now, I will see a gray screen pop up. There should be nothing happening. I've got an empty array list. Now I'll start clicking. Look at how many ball objects have now appeared. I'm going to go ahead and stop this program. It runs pretty quickly, but if you notice now, there are tons of ball objects that exist inside of this array list. When we print out just the ball itself, it's telling you the location of where that ball exists on the computer, which is not what we care about, but what we can see is there are many ball objects inside of this array list right now, which is great. But that's not exactly what we want to do. In the end, we want to actually access those ball objects and make them appear on the screen. So we could start to say something like, okay, let's call ball B1 equals ball list dot get that first thing in the list, so at 0, and then we can draw the ellipse at b1.x and b1.y, and we'll choose the size, so I'll make it 10 by 10, and then we can tell that ball to move, and likely we'll want to, before we draw that ellipse, fill with some color. So let's fill with, I don't know, red. Keep it easy for the moment. So now when I click this time, I can add as many as I want. Clicking adds them, but the only thing that I'm going to see appear is once I've put a ball into the list, I'm going to make that first ball object in the list perform its actions, and only that one. So let's run it now and see what I've done. All right, Oops, what did I do? Ah, got it. Here we go right away. I don't have anything in my list yet, so I can't actually access this. So let's do it inside of here, because then I will have for sure put something into my list once I press the mouse. So let's try that. Okay, so I don't have anything printing out, but I've got an empty list. I forgot that I turned off that print statement. So I've got an empty list, and as soon as I click one time, I see that one ball object, and then I never see a ball object ever again. They are gone forever and ever and ever, and I never get to see it again. So it's gone. There's nothing I can do about it. That's it. But I've only got that one printing out right now. So I could do this over and over and over again for every single ball object that's inside of this ball list. But imagine how tedious that will get once there's 10, 15, 500 ball objects inside of that list. So instead of accessing each one individually, we want to instead loop over the list of ball objects. To do this for each ball object. So I'm going to take all of this part back. We're going to move it down here, and I'm just going to go ahead and comment it out because this is not the lines that I want to do. So let's do it in real code. So now we're going to create a for loop that's going to start at 0 because remember we want to have this loop over all the indices of the loop. So it should stop when we reach the length of the list, and it should increase by 1 to access each element of this list. And then the actions that we want to perform are exactly what we had written in here from before, but this time we don't want to get the 0th thing. We want to get the thing that's at index I, and we'll call that B1 for a second. We'll draw an ellipse at B1 and then make B1 move. Now I'm realizing that I don't want B1 to just move. I actually want B1 to act. So I'm going to change that because I have an act method in here that's better than my move method that calls that add gravity as well. So now this part was something that you copy and pasted from me. And in fact, it probably didn't even have a full color in it when you copy and pasted it. But what this loop is doing is going to each element inside of ball list. So it's going to each individual ball object. It's momentarily saving it as B1 and it's telling the computer to draw it at its X and Y position and then act accordingly. And so it will do that for each object that exists inside of ball list. And then it'll, when it finishes, draw method runs again and it will perform again. So every time this draw method runs, we're accessing all of the ball objects inside of that list, making them move just a fraction of an inch, and then that draw method repeats over and over and over again, and that repeated tiny movements of moving in the for loop and then redrawing allows us to appear as though we have motion. So when we run it this time, we should now see that when I click, until I click, nothing happens. Right now I've got an empty array list, but as soon as I start to click, ball objects appear. And then once they leave the screen, they never come back because they exist and the graphics program lets us draw them off the screen so we don't see them. But when I'm clicking, they appear. And they move just for a little bit, for a few frames of draw. And then they move off the screen and we no longer see them. But there we go. That's all of the code and pieces from the exercises that I asked you to copy and paste. The big part was this bit right here. The other part that I asked you to copy and paste was this add gravity method, but hopefully by the end of this video now, those two things make a lot more sense.